mathematicians. Sorry, had some mic problems. Okay. Where were we? Learning spectral sequences, of course. And what can one say about that? Mathematicians. All the velocity of my sub increases has really slowed down. Oh, sorry, had some mic problems. Okay. And where were we? Learning spectral sequences. I should probably make more your proofs or trash videos. People watch those. They don't watch my group theory, my group cohomology videos. Hello everyone. Good morning. Yeah. Okay, so we were going to compute cohomology of projective 3 space. That's the plan for today. So let's do it. Just in time for your own coffee. Nice. I made pour over coffee this morning, but it was my first time doing it, so I made it. I know, Locke, that you like group cohomology videos, but my recent videos are all on that topic are all under 1,000 views, and my your proofs or trash videos have like over 30. I mean, I just got it in my mug here, and then the rest of it is in thermos. To keep it warm. I'd say it tastes pretty good, but it's a little weak. So maybe a finer ground tomorrow. But also, I made sure to get like a Pyrex one, but I realized my kettle is all made out of plastic. So now I want to go buy a metal kettle. So I can have less microplastics in my body. But it also feels hopeless, like there's no avoiding it. Anywho, so RP3 into, this is an S1 fiber over S2. So let's see. Let's set up our E2 page. So E2 ST E2 Brute. E2 ST is E S B. No, I think I have it backwards. The fiber goes first. F for first. Right? Fiber. No, okay, it is the base first. Okay, I was right. BS. HTF. So the fiber is S1, so we know we're only going to have our bottom 2 rows. Let's go. You can watch a spectral sequence, do spectral sequencings in real time. Hell yeah. That's the whole point of the series. Can you get into mathematical research in a country that doesn't support scientific research and also with no PhD? Probably not. I would say most likely not. I mean, I have no idea about a country that doesn't support mathematical research. I assume that makes it a lot harder. But I don't live in a country that doesn't support mathematical research, and nor have I ever. So I don't have personal experience with that. I can only guess. Certainly with no PhD, very unlikely, I would say. No, there's still, I was talking to someone recently. There's like hobbyist journals out there, and there's probably still some there's, it's possible that you could make some contribution that would be of interest enough to at least go in one of these hobby journals. Um, and also, I mean, I could imagine that there are other avenues that you could take, non-traditional avenues through, yeah, it probably depends on the country. But non-traditional avenues through research, like somehow, if you made your way into data science or something, and worked back from there, and ended up getting to a point where you made an original research contribution and something related to that. Like, I could imagine that that is possible, but I don't know. The problem is, for most areas of mathematics, um, without a PhD, it'll just be very, very difficult to get to that level. And you could say, well, with enough time, couldn't I get to that level of knowledge? But it's very hard to do it on your own. The point about a PhD is, you're getting a stipend, so you don't have to worry as much about other things. You can just be immersed completely in mathematics. You have some sort of guide that can help direct you through it, because the journey is a lot longer without a guide. So, yeah. Stoning of mathematicians. Well, I don't know if stoning of mathematicians is a thing in any world. You should look into hobby journals. That might spark you to learn some math properly. Yeah, maybe. You don't want to die with 0 papers published. Well, I mean, you could, yeah, I don't know. It'll be difficult. I'm going to say it's unlikely. I'm going to say it's not impossible. But I think even when you take a traditional path to mathematics, you have to make sacrifices, right? Like, to become a professional mathematician, you are not going to be able to spend your entire life in your hometown. You have to move around a lot on your way to getting there. So, for example, if your desire to not die without publishing papers is stronger than your desire to stay where you are, then you should probably leave if that's a barrier to you doing mathematics. And granted, that might be hard. That might be hard. You might be in a position where that itself is a difficult thing to do. But you imagine you can become a good mathematician outside of an institution, but you guess being able to converse and work together with other mathematicians is a big buff. Yeah, exactly. Very difficult to become good in isolation. Code Parade got a math paper. I don't know who that is, without really being a math researcher. So doable, sure, and then in parentheses with another researcher. Yeah. So clearly some other collaboration. I mean, so yeah, nowadays with the internet, maybe it's easier to be able to do that without leaving home. I don't know. Well, Goddard, I hope you're planning on living a very, very long time, because for the average human lifespan is nowhere near enough time to learn all of math. Probably 20 human lifespans isn't. Probably 100 human lifetimes isn't enough to learn all the math that currently exists. And more papers are being published every day, so will be difficult. Okay, let's do some math. Enough yapping. So let's see. In any cases where this is non-zero, this will be z. In any cases where this is non-zero, this will be z. Yeah. So we just need to put in, so what? We'll have Z, right? H2, wait, H0 of S2, 0 of S2, that's the X. Wait, S is the X-axis. Hang on. Right. So both of these will be Z. H1 is 0, and H2, they'll both be Z. So it's just this. Paul Erdish frequented his friends' houses just for math. That is true. That is definitely true. It's also just a guess, and you trust the mathematics researcher in the room on this one. Yeah. I mean, I could be wrong sometimes. But don't tell anyone that. Don't tell anyone I admitted it. Erdish was called a spy by the FBI because of his antics. Yeah, I mean, to be fair, if I was working for the FBI, I probably also would have thought that he was sus. Functional analysis and rep theory are the two branches you want to check out next. Well, they go together really, really well. They go together really, really well, so. Okay, so here's my guess. I'm pretty sure all of these differentials are 0, so it just collapses at the E2 page. Yeah, I mean, you can't do representations of like Lie groups, for example, without functional analysis. So I'm guessing it just collapses at the E2 page, right? And now I'm starting to be able to just do things purely visually. I mean, definitely that's true for these ones. And then I guess the only question is, can you move over 2 and down 1? Yeah, that's possible. That's possible. So let's see. These could potentially hit each other somewhere. Where would that be? So dr h, what's this? 0, 1, 2. This is 2. So it would have to be on the E2 page. If they're going to hit it at each other anywhere, this would be 2, 1, minus 2. Yeah. Okay. So we've got a non-trivial. We've got a, well, could be trivial, but we've definitely got a differential here. And now we want to ask about its kernel and co-kernel, I suppose. Does complex analysis build over real analysis? Sort of. I mean, you could potentially just jump right into complex analysis instead of real analysis, but it's probably better to spend a little time on real analysis first. Well, what do you mean by larger? What do you mean by the set of complex numbers is larger? In terms of cardinality, no. As a vector space over the real numbers, yes, it has larger dimension. But depends on what. If you mean in terms of cardinality of sets, it is not larger. Oh, Paul Maurice, hello. It's been a while. Haven't seen you for a while. You might be wrong, but you think they just have bits of intersection? No, there's a lot of intersection between functional analysis and representation theory. Oh, sorry, you were maybe talking about real and complex. Yes, this is well, it's this. I mean, it's kind of a, you take a quotient of like the hop vibration, and we're using a spectral sequence calculation to compute cohomology of RP3. Do I sometimes work along applied mathematics? Not yet, but who knows? Maybe one day I will. You hope to be studying math in the future, but the only university you have access to offer applied math programs. Well, you can always start there. If that's the only place you have access to, you can start there. And I mean, definitely the difference between pure and applied math isn't some hard boundary, right? There's certain math you can point to that's very far away from applied, and math you could point to that's very far away from pure. But there's certainly ones that are very hard to put firmly in one camp over the other. So go to university, start studying applied math. Maybe you'll find you like it and you want to stick with that. But then you could also, possibly you go to university, you get a bachelor's in applied math, and maybe it's on the theoretical side of that. And then maybe you go to grad school for more pure math if you want. Reading philosophy is harder than doing math. Yeah, I would agree. You have to literally read a page for a full hour. Well, that can happen in math too. If you know about Hegel. Yeah. I don't know. I was saying this to my friend the other day, like, maybe Hegel just sucked at writing. I don't know. I've never spent any time actually trying to read Hegel, but everyone's like, "Whoa, Hegel." And I'm like, yeah, maybe he was just shit at trying to communicate his ideas. Have you ever thought about that? Maybe he wasn't that, well, maybe he was deep, but he was just bad at expressing his thoughts. Okay. Why would that be surprising? Everything has connections to category theory. Okay, so we want to think about this thing. We've got this differential. This is D2. I guess what? We look at E. Let's look at E301, which has to be the kernel of E201 to E220 modulo. The image is going to be 0. So, right. Oh, maybe like last time we have to use the algebra structure here. Maybe we have to use the algebra structure here. So we know that we have an x here and a y here. And we know that x times y, generates the other thing. The most surprising thing... Hegel led to development of category theory? No, I don't. I mean, I don't think I agree at all. No, certainly people have gone on, to formalize Hegel, but he did not. I would not say he led to the development of category theory. Yeah, sorry, I did Hegel dirty. You've seen an assumption of simply connected of base spaces simplifies a lot of calculation in spectral sequences. Oh, interesting. I haven't encountered that yet. In the Serre spectral sequence, if the base is not simply connected, then you have to use cohomology with local coefficients. What does that mean? What do you mean by local coefficients? Yeah, but category theory is used a lot of places. So still, I would say it's not super surprising to me. Okay. Let's think. How did we use... Okay, let's look at the last example. How did we make use of the algebra? What did we do in that case? The ring structure is also easy to extract. What did we do here? The domain is generated by these. Note that those are both 0. So by the Leibniz rule, we have this. So D9 is also 0. I'm not sure if that helps us here. You mean cohomology with coefficients in a local system? Oh. Wait, local system of abelian groups? I mean, for me, local system implicitly means sheaf of vector spaces. You just mean locally constant sheaf of abelian groups. More generally, because the cohomology of the fiber might be acted upon non-trivially by the basis fundamental group. Oh, so maybe you do mean local... I mean, of course, local system in the vector space sense is abelian groups, but you don't mean more general than local system of vector spaces, do you? Okay, there was some step I was confused about how he argued the structure here. Maybe if I go back and read that again. In this case, we can fill all the groups. Right, I mean, it's very similar to this case. Yeah, but the problem was this just collapsed for degree reasons. So we need to look at the other case. The ring structure is also easy to extract. Let these be the generators. Yes, and I didn't quite understand why that became the exterior algebra. Right, there was some missing thing about the grading there. Yeah, vector spaces are abelian groups too, but I mean, normally if someone says to me local system, I'm thinking that this is a sheaf, a locally constant sheaf of vector spaces. And so there would be no need to say abelian groups. So when you say abelian groups, when you add abelian groups to that, that makes me think that you're saying it can be more general than vector spaces. And I'm just ensuring that that's not the case. Why should fundamental group action play a role in cohomology? That's actually a good question. Well, I mean, it's not surprising though, right? Was that second paragraph saying cohomology ring is an exterior algebra? Yes. Do I have any non-textbook math books that I enjoyed reading? I mean, I've got, there's I Want to Be a Mathematician, and Automathography by Paul Hamosh. I've got some books on math history. Those aren't text. Well, they're kind of, one of them's kind of a textbook. What else? What else do I have? I have the book Mathematical Apocrypha, just a bunch of stories. There's Love in Math by Edward Frankel. I definitely read a bunch of those a lot of those pop physics books back in the day. I have this book. I haven't really dove into it yet. It's called In Pursuit of Zeta 3. There is a lot of integrals in it, but it's not, I wouldn't say it's quite a textbook. What else do I have for non-textbook math books? Yeah. I mean, it's also like, what is your definition of what makes something a textbook and not? There's also this book I have called Gamma. And it's all about the constant gamma. But there's a lot of serious math in it. But it's technically not a textbook. Hello, Kostaka Kori. Well, if you do want to do category theory, Lever's work was deeply intertwined with philosophy. Sure. That doesn't mean you need to... and he developed the elementary theory of category of sets using dialectics. Sure, but you also can just do pure category theory and never have to worry about philosophy. Yeah. Okay, so same reasoning allows us to determine here. There are two non-zero differential groups at different degree 6. The spectral sequence therefore collapses for degree reasons. No, that one was again degree reason collapse. Next in line is this. Most differentials are necessarily 0 for degree reasons, but there are 2 D9s that need to be determined by further argument. This is a situation where we need to use the ring structure to work out all the cohomology groups. Okay. The domain is generated by... Yeah, the problem is the Leibniz rule isn't really going to help us here, right? By the Leibniz rule, we have this. You are talking about something more general than vector spaces? But then, I mean, okay, whatever. I'm quibbling about terminology here. But if someone says local system, that to me specifically means like a sheaf of vectors, a locally constant sheaf of vector spaces. Sheaf of anything could be locally constant, sure. But okay, and then the fundamental group is acting on the abelian group in a G module way. On the sheaf in a G module way. I guess that's still... yeah, I guess the same way that you have it act on local systems still makes sense. I guess there's nothing special about it being vector spaces there. So then actually, do we get... I mean, normally we talk about the equivalence of categories of the category of representations of the fundamental group being equivalent to the category of local systems. But really, you could just make it like the category of pi 1 modules being equivalent to the category of local systems of abelian groups, right? Like the same proof should go through. Is that true? Okay, so let's see. I think this is an example where we're supposed to not be using information about the E infinity page. We're supposed to be trying to derive it. So, let's see. We've investigated that. When do we have the image of these things on the bottom? Well, we could look at E3 of 0, 2, which is supposed to be the kernel of E2, 0, 2. So this will be everything. Modulo this image. Yeah, again, it doesn't really tell us anything. It doesn't really tell us anything. Okay, wait a second. What if we do use the Leibniz rule on x and y? So we know that the differential of... No, it doesn't tell us anything. The weird thing you were trying to do with cohomology rings that are exterior algebras was attach a symmetric bilinear form to them to convert it to a geometric algebra. and then see what the geometric product means on cocycles. Well, probably you'd want the geometric product to just align with the product in the algebra, right? Which would just be the cup product. What does that fundamental group action do for the cohomology? Does it make it compatible with Poincare duality or something? I have no idea. Maybe Rod can answer that. Okay, so we might have to look at this. So I do wonder, I was thinking about this. They use these quotient maps, which should induce some maps on cohomology. So maybe there's something there. We already know this. Why do we already know these? We know the first one. Why do we know that H3 is Z? I mean, technically this is all worked out, but was that from our previous calculations? No. Why should we know? Why should we know such things? Oh, I guess that's just general cohomology facts, maybe. Wait, no, because isn't this... No, why would we know that? It's basically analogous to a monodromy action, but it doesn't do anything. It just exists. Why would we know that H3 is that already? I mean, I guess if we knew that H3 was that already, then does that save us? No, that doesn't help us. Well, I guess we know that from here. The cup product becomes the wedge product by the standard isomorphism. Sure. The symmetric bilinear form gives rise to the geometric product. Ah. I see. Poincare duality? Oh, yes. Right. I guess RP3 is compact, so I guess we can apply Poincare duality. But I guess this still won't help us for... that still won't help us for these two, right? Yeah, it still doesn't help us for these two. I mean, I guess we know it by Poincare duality, but we also know it just by looking at by just seeing that, like, this thing survives to the E infinity page. To fill in the remaining groups, okay, we do got to use some tricks about this quotient here. We need to work out what D2 is. Right. So if we use the fundamental group, and we use the fact that, so H1 of RP3 is the abelianization of RP3, which is the abelianization of Z mod 2, which is Z mod 2, then we know that Z mod 2 is H1, which will be the sum of E infinity 0, 1 plus E infinity 1, 0. Now 1, 0 has to be 0 because there was nothing there to begin with. So in other words, we know that E infinity 0, 1 has to be Z mod 2. And that can only come about That can only come about at this stage of the game because none of the other differentials will hit. So, so that means we have, right. So then that means that E3 01, no. Yeah, that means that E301 has to be Z mod 2. So that means that the kernel, that means that the kernel of D2 here, the kernel of D2 is Z2. So probably that means that, homology. Okay, sorry. I see. Right. Okay, hang on. We got to go back for a second. You're right. So that's our first homology, but can't we relate this to cohomology somehow? Can't this give us information about cohomology? By Poincare duality. By Poincare duality, it's H2. Right. By Poincare duality. Wait, let me just... Right, because it's the... Right, it's with the cohomology, the like compact... Right, compact manifold. Right. Yeah, upper versus lower. Okay, sorry. Okay. Right, sorry. I got that backwards. So, it's that... So, okay. So we know then that actually this is H2, rather. So, and this is just going to be E2, 0. So, what does that mean? Well, we could look at it as E, wait, on the infinity page. So this means that E3, 2, 0 is Z mod 2. And that's Z, right, and that's Z modulo. The image has to be 2Z. So I think this means that X should go to like 2Y or something, right? X should go to like 2Y. X should go to 2Y. Right, because if I go Y mod 2Y, yeah, then I just have two things in here. I've got my identity, and I've got Y, like 0 and Y, and add Y to itself. Yeah, C mod 2. So it should be something like that. Right. And then H3 of 0, 1 is going to be the kernel of that map. So, but I guess this is injective. So the kernel 0. The kernel 0. So the whole thing 0. So H1 should be 0? I feel like I maybe did something wrong. So H0 is Z, H2 is Z. Oh no, right. Right, projective space, we shouldn't have anything in odd dimension. Wait a second, but that's not true because we want H3 to be also Z. The spectral sequence is spectraling. It is indeed. It is indeed. Well, Leo lectures, I've almost learned something. That's how it's going. Oh, and I'm out of coffee. See, that's a problem. When you make the coffee a little too weak, it feels like you shouldn't be done. How many rules of inference are used in set theoretic maths, ignoring others? Are they all first-order logic? That's a good question that I don't know the answer to. I have no idea, actually. Right. Okay. So there's... Oh, I was right. I was right. So H1 is 0. Okay. ZFC is built on first-order logic, so you think all of them. Well, all of the rules of inference of first-order logic, but then the question would be, how many are those? Would I ever try to solve a Millennium Prize problem? No. Of course, as an undergrad, you play around with the Riemann hypothesis a bit. Why not? But everything I've worked on, nothing I've worked on has the skill sets I've cultivated aren't really related to any of the Millennium Prize problems. So, if I wanted to, I would be starting from scratch, basically. And I just don't think it's worth my time. I mean, maybe if I had ended up in an area of research related to those problems, I would be working on stuff related to those problems. But you don't like the typesetting in RP3? Yeah, neither do I. Should be math bold P. Yeah. So what's this step 9 here? Last two steps are cautionary tales of sorts. We have so far had an easy time reading off cohomology groups from E infinity, since there's only been at most one non-zero group in each degree. However, there is often a lot more to it. Consider the mapping from S1 to U2 going here. In addition, we may identify SU2 as S3, and so we get this. Thus, it fits into a fibration here. We'd like to use this to compute the cohomology of U2. You would? You bet that the big professors at universities are missing a small trick that only you could think of? Great. Well, can't wait to see your papers drop. Right. There is that weak link of P equals NP to Kazenlichtig polynomials. That's true. Yeah. Emphasis on weak, I suppose. I don't know. As usual, we begin by plotting these and then filling in the remaining groups. Right. So, yeah, in this case, the fiber is S1, so we're just going to have the two rows being non-zero, and then the rest is just filled in by the cohomology that we already know. Since H2 of U2 is 0, wait, how do we know that? How do we know? Why are we just pulling that out of our butts? Did we? Well, where is that coming from? Oh, well, U2 mod U1. No, I don't know where that's supposed to be coming from. If you're looking for Millennium problems related to geometry, P and P is way above the bar. Yeah. Have they even tried contradiction? Well, no, they're all constructivists, don't you know? Bold of you assume we know anything. Yeah. Yeah, I don't know why this is true. Oh, maybe for dimension reasons. What's the dimension of U2? That's bigger. It's at least 2. Okay, whatever. I'll just believe it. The only chance to kill it is for this map to be surjective. No other space for other differentials nor higher differentials, as everything outside the bottom rows are zeros. So collapses to E infinity. From this, we can read off the groups 0, 1, and 4 directly. However, in degree 3, we have Z mod 2 and Z. Interesting. And we're left wondering how to put them together. I see. So we don't know if it's a direct sum or what. Computational problem? Huh? You think cryptography would be the first to die if something happened in P equals NP? Yeah, well, what if we have a non-constructive proof though? Do I know any unsolved problems in geometry except Poincaré? Poincaré is solved. So, that's not even an example. Do I know, yeah, the Hodge conjecture. There you go. Boom. Millennium Prize problem. Unsolved problem in geometry. Yeah, there's lots. I don't know. Here's an unsolved problem. Find an algorithmic way to... Actually, I think there's a way to answer this already. Never mind. But maybe it's not easy. Cryptography is so lit. You love outclassing CPSC master students with your esoteric algebra knowledge. Or if you have... or if you solve NP complete problem in like n to the 50 time. Yeah. Yeah. Yeah, I mean, people talk about like, oh, cryptography would fall, but like, well, yeah, I don't know. Anywho, let's just see if I can quickly read through the rest of this, because I kind of have to go. But this would be a good time to leave. But I kind of want to leave off. Actually, no, I'm gonna leave off here. And we will just finish up this document at the start of tomorrow. And then I think I might crack open a Luffy and learn about exact couples from there. I think that's the plan. That will be the plan for tomorrow. You love elliptic curve cryptography because you can see so many ways to bombard sane people with algebraic geometry. And that's the dream, really. So... have fun, go bombard people with algebraic geometry, and tell me about how that went when I see you back here tomorrow. So Q, E,